Thanks everybody for joining this session about how scaling MySQL for the future and how ProxySQL helps in achieving this. Okay, first of all, quick introduction. What is the agenda for today? First, we're going to have an introduction about who am I, what I'm doing, and then what are the challenges in scaling MySQL nowadays that is different than how it was in the past. We're having a short introduction about ProxySQL, what is and what is capable of doing. It has a lot of features, but of course we will focus on just the feature related to scaling MySQL. Then we're going to exactly discussing how those features can help in scaling MySQL. And then we're going to have a look at real-world use case scenarios and what are the architecture in which ProxySQL is being used. And then finally, we'll have some summary, so some takeaway and Q&A, so open to questions. Okay, next, who am I? I am René Canao. I am the founder and CEO of ProxySQL. I have roughly 25 years of experience as database architecture and performance optimization. So basically all my past has been related to working with database, specifically MySQL. I have been a MySQL consultant for quite a long time and also performance expert and doing a lot of consultancy over the year. As a consultant and working with MySQL, I have seen so many use cases in which MySQL was not able to scale. I wanted to solve some specific issues. This is where I decided to actually start developing ProxySQL to solve all those specific problems that I was encountering in my career. And yes, finally, I'm basically very passionate about performance. This is my main focus. I am an active contributor in the MySQL community and trying to always participate to those events. Okay, thanks. Next, so what is the problem of MySQL nowadays? So first of all, we should acknowledge the fact that the way MySQL is being used now is different than the way it was used 20 or even 10 years ago. Back in the past, it was very common to have just one web server, maybe a couple of web server maximum, and on the backend side, on the database side, there was one MySQL server, maybe two. It was quite common to have no more than two servers, like one for doing all the work on it, and another one for just backup or failover in case something really bad was happening. Nowadays, the landscape in which MySQL is being deployed is completely different, in which we have data that is being generated on an exponential pace, so there is always more data that is being stored and more data that is being processed. So the way MySQL used to work in the past is not sustainable anymore. And this also means that there were some design embedded in MySQL that worked very well in the past and they are not working great in the current days. For instance, one of the common problems with scaling MySQL is that it doesn't work very well with an elevated number of connections. The reason is that in MySQL, one connection equals to one thread. So every time a client connects to MySQL server, it starts one thread. And this means that even if the client is idle, they're still using memory and they're still using CPU, and the operating system has to handle this thread and so on. Later, we will see exactly how a bit more details about this. Of course, if the operating system, the server is busy managing thread, this means that the query execution might increase, so increase latency. This also affects user experience because the application becomes slow waiting a response from the database, and so it ends up with negative user experience. And then we have several issues related with read and write, because one of the common way of solving this problem of an overloaded server was to add read replica. This works with scaling reads, but it introduces a set of problems. Specifically, it increases the complexity of the environment because now we have replicas that are replicating from the writer, so you need to ensure those replicas are in sync. You need to ensure that when you read from them, the server is in a healthy state, that you not create load there as well, and so on. So it also creates a more complex topology, again, because you are basically adding more server and more things can break. Okay, next. So as I was saying, some of those limitations are built inside MySQL in a way. So for instance, as I mentioned, there is a thread per connection architecture. This means that it cannot scale beyond a certain point. So the more connection you created, the more the server is affected in terms of performance. So if you're running MySQL in the past, you know that if you go beyond a certain number of connections, then performance starts to degrade very fast. There is no built-in load balancing, and this is absolutely normal. You cannot expect a load balancing built-in inside the database, so you need to have some load balancing outside of the database. There is no failover automation built-in MySQL. That's in a classic environment in which you have one writer and multiple replicas. This is not true anymore if you're using some clustering solution like DB cluster or group replication. But I will going to explain those later on. And then you also, because there is no built-in load balancing, often the application need to have some logic of where to send the writes, where to send the reads. So this logic often has to be built in inside the application. You can use some proxy in front of MySQL. Classically, you can use HA proxy, LVS, or any sort of network load balancing. But all those proxy has built-in limitation, that is the fact that they are just TCP load balancer. So they do not understand anything about the traffic that is passing through them. So they are not SQL aware. They don't understand what is the traffic that is going through them. So they don't understand the SQL command. Again, another problem is that replication lag might break, or might break consistency assumption. So one of the application might be reading from a replica without knowing if the replica is lagging or if replication is broken at all. And of course, this means that you might make the application aware of all of this, but it's absolutely increased complexity. Because of some of those limitations, but not only those, this is why ProxySQL was developed in first place. And one of the most common features of ProxySQL is exactly the connection pooling and multiplexing. That is basically the ability of ProxySQL of keeping a very small number of connections to the database, and using those backend connections is able to send requests from a way larger pool of client connection. So you may have thousands of applications that connect to ProxySQL, and then ProxySQL just use 10 or 20 connections to the database. So it is able to track the status of those backend connections, and it knows when those backend connections are safe to be reused. So because of this, it's absolutely able to reduce the number of threads that are created on the database server, and so improve performance. And this is just one of the features, and then it's also query aware, so it's basically able to understand the queries, and based on this, you can create rules in which you can configure ProxySQL where to send the traffic. It has, although ProxySQL is not able to perform any sort of failover, it is able to detect failover. So if you have a third-party tool that is performing the failover, or if you're doing it manually, that's surprisingly, I've been speaking with people yesterday, there are still so many people that are doing failover manually. So no matter how you're doing the failover, ProxySQL is able to detect this and will automatically redirect the traffic. It has also some interesting features like query caching, query rewrites, and traffic shaping, but I'm going to describe them later on, and also has fine-grained observability and access control. So everything that goes to ProxySQL, you are able to observe it, so you get statistics from it, and you can create also rules on what is allowed and what is not. Now, one of the common problems with MySQL and increased number of connection is connection storm and thread exhaustion. So as I was mentioning, one connection is equal one thread. So it is very common, especially nowadays, in which you have so many microservices that all the microservices create its own connection pool to the MySQL server. So it is common to have a lot of MySQL connection, but only few of them are active at any time. And this is just one problem. because those connections that are creating threads, they might potentially exhaust the operating system resources, so you have performance degradation. But even more interesting is when you have a connection storms. So like, for example, you are making an application redeployment, or you have some network issue, and for a certain period of time, the application was not connecting, and then all of a sudden it creates a lot of connection, or you have a special event like quick sale, or a sport event, event like Black Friday and so on, in which you have a huge number of requests coming at once. Normally what the application do is to just create more connection to the database server, and well, this is absolutely a bad approach, because the more connection you have, the worse performance you get. So instead of getting more work done from MySQL Server, it's actually you end up in a situation in which the MySQL Server struggle to even reply to very basic queries. Things becomes even more interesting when the application tries to be smart and has some built-in timeout. I have seen this many times. For example, the application creates a lot of connection, and it starts running queries, or even worse, it starts running transaction. And the application has a built-in timeout for the transaction. So let's say that the server becomes busy and the transaction is slowing down. The application detects, oh, the transaction is taking longer than expected. So the client disconnect and reconnect immediately, try to execute the transaction. So this actually makes things worse, because now you have the MySQL server that is trying to perform a rollback, and that is an expensive operation, because InnoDB is optimized for commit and not for rollback. So while the MySQL server is performing the rollback, you have the client that is reconnecting and trying to execute the same transaction again. So you end up in a situation in which things are stalled completely, so you make absolutely no progress. Okay, so this is where ProxySQL is able to solve easily this problem, because it is able to limit the number of backend connections to the server. Those limited number of connections, they have multiplexing enabled, so the same few backend connections can be used to serve traffic from multiple clients. What if those backend connections are already busy? Well, that's not a problem, because ProxySQL, what it's going to do is it just schedule those client requests to be executed, to be sent on those backend connections as soon as they become ready. So this means that it's drastically able to reduce the load on the MySQL server, and is also drastically able to reduce the memory footprint on the MySQL server. So the MySQL server, it will be actually busy in doing work instead of managing a huge number of connections and just context switching between them. And the last point is that as we have many users that after they deploy ProxySQL, they think there is something wrong, because they see the number of connections to the database server drop by a factor of 100. Of course, this really depends from your type of application, because, for example, if you're running transaction, the drop of connection cannot be that large. But yeah, it's very common to have users that they pass from 5,000 connections to 50 overnight, just because they deployed ProxySQL. Okay, next. Another common problem is when you scale out, you're adding replicas. This works great if you're just sending to those replica some select statement, but then it starts becoming a bit more complicated if the application are lag sensitive, so they cannot send requests to servers that are lagging, or if they accept only a certain range with lags, like the replica cannot be lagging for more than a few seconds. So if you are connecting directly to MySQL, the application need to be aware of the replication lag of the replicas, if replication is running at all, and so on. So this creates some complex logic in the application, and this can be easily solved by ProxySQL, because if the application connects directly to ProxySQL, the application does not need to know anything about replicas, so it doesn't need to know if the replica is lagging, doesn't need to check if replication is broken at all, or how much is lagging. So the application only needs to send traffic to ProxySQL, and you need to configure ProxySQL to send traffic to a replica only within certain criteria. So like only if replication log is within a certain range. The application does not need to know anything anymore about the replication log. Okay, another common problem when the application connected to MySQL is what happened during a failover. During a failover, well, what you have is that the primary node becomes unavailable. If you have the failover detection built in the application, this becomes extremely complicated because the application somehow needs to detect that the server is gone. And this part is probably the easiest one because they simply get errors when they try to connect or to send query. But then there is the discovery part. So the application somehow need to be reconfigured to point to the new writer, and then you need to verify if the replicas are replicating from the new writers and so on. So all this logic, if it is implemented in the application, become extremely difficult to maintain. And depending also from the application, reconfiguration of the application often means a restart of the application. I have seen application taking 30 minutes or even hours to restart because of their complex bootstrapping. So this is extremely dangerous situation. And also there is the possibility during a failover that the application ends up in a situation in which it's writing to multiple servers at the same time if there is, for instance, a network partitioning. ProxySQL solves all those problems listed before. So no matter what sort of failover happen on the backend, ProxySQL is automatically able to detect this. And without any configuration change, the traffic will be automatically redirected to the new primary. Another interesting thing is that from the application point of view, nothing happened because the application is still connected to the proxy. So even if the backend failed and the backend is gone, the connection from the client point of view, they are still alive. What the application can notice is some slight latency, because if the application is sending a query and there is no backend, ProxySQL will hold those requests until a backend becomes available. So from an application point of view, there is no error. There will be just slight latency. And the latency might be just 1 or 2 seconds, depending from the type of failover. As I was mentioning, ProxySQL does not perform the failover itself, so you need some automation that perform this. And this really depends from the clustering solution you're using. Like if you're using a DB cluster, I'm going to describe this further in the next slide. Or if you're using Galera or any cloud solution. So depending from the failover, from the clustering solution, ProxySQL can detect that the failover happened and automatically reconfigure itself, and the application is not affected. Also, ProxySQL recently introduced a way of protecting from split brain scenarios. So even if you end up in a situation in which you have multiple writers, for whatever reason, network partitioning or wrong configuration and so on, ProxySQL will prevent writes from going on both servers. So it will basically stop any sort of writes until this is solved. So what about InnoDB cluster? InnoDB cluster actually has a built-in HA solution. So servers are able to detect who is the writer and promote the writer. But there is still the problem that the application needs to know which one is the writer and which one is the reader. If the cluster grows or if the cluster shrinks, you need the application to be aware of this. MySQL router solved this, but MySQL router has way less capability compared to ProxySQL. Later I'm going to describe them in details. Okay, I'm getting late. Okay, so another common problem is the presence of overloaded replicas or spot. So if you have a replica, because it is possible that not all the replicas are identical, so you may have some replica that is that has better hardware or that has less queries. So ProxySQL is able to detect which is the best performing replica or which are the replicas that are not performing so well, and is automatically able to rebalance the traffic automatically among those replicas. Next, query routing cows. So again, if you have the read-write split logic implemented in the application logic can actually becomes quite complex, especially if you don't have just one application, but you have a lot of microservices. And as more microservices you add, and this is something very common in big corporations right now when you have multiple teams, the routing decision becomes extremely complex. And all the application will need to define where the read and where the write goes. Again, ProxySQL is able to solve this automatically because you just configure ProxySQL on when the traffic need to go. And the way you configure it is through a series of rules. And the rules could be anything from a regular expression on the query. It could be a schema name, a username, or other metadata like the client can send some identifier in the query, and ProxySQL can be configured that, okay, if this identifier is present, the query needs to go on a specific set of server, and so on. So you're able to implement read-write split with absolutely no change in the application, and this is one of the strengths of ProxySQL. And you can define read-write split or any other sort of routing on a per query basis, so extremely fine-grained control. And all those rules are dynamic, so you can change them on the flight. The other important things is that ProxySQL is able to handle thousands of clusters simultaneously. So a lot of other proxy solutions, they are only able to support one cluster as a backend, while instead ProxySQL is able to handle thousands. And we actually have users that have hundreds of clusters behind one single ProxySQL instance. And to be clear, not thousands of servers, but thousands of clusters behind one single proxy. Okay, next, query caching. This is another feature that is available in ProxySQL. So if the application is running the same queries over and over, and the result set is mostly static, ProxySQL has a query cache that can be used to serve this sort of result set directly from its own built-in query cache. But this works mostly for static result set. In fact, it is based on TTL. So the invalidation is based on TTL and not on data being updated. If instead you have a situation in which you want your data, the result set of the query to be cached, but to be automatically updated in real time and invalidated in real time, we strongly recommend to use ReadySet as a backend behind ProxySQL. It works extremely well. Okay, thanks. Next, another common problem when client connected directly to the database server is that clients often do not have any sort of observability. So like they do not log on, they do not log why the query failed or where the query was sent and so on. And so when there is a problem, it's extremely difficult to perform some sort of troubleshooting or trace those errors to which server it was failing. ProxySQL what allows is to have observability in real time. So everything that is passing through ProxySQL can be logged optionally, but there are all statistics that are being gathered in real time. And those statistics are built inside ProxySQL, and you can query them directly inside ProxySQL, or you can export them and you can make them available in other monitoring tooling like Grafana, PMM, or your own custom dashboard. Okay, next. Another common issue when the application connects directly to the database server is that you have a very tight coupling between the application and the database. This means that often the developer of the application need to know the database topology, what are the IPs of the database server, and so on. This makes the code quite complex and difficult to maintain. Instead, with ProxySQL, things become extremely more easy because the application only need to connect to ProxySQL, often through localhost or some middle layer, and the developers do not need to care anymore about the database topology. They only need to take care of the business logic and developing the application. So they don't need to care about the replication lag. They don't need to know if the database is actually asynchronous replication, DB cluster, or any other solution, the application does not need to know anything about the database infrastructure. This also means that the operational team can perform migration or failover or scale out, scale in, adding server, removing server, absolutely transparently from the developers. Like, none of the development team need to know that some maintenance on the backend is being performed. Okay, next. Okay, going a bit faster. Okay, so another interesting features of ProxySQL is the ability of rewriting queries on the fly. So if you're able to identify some query that is performing poorly, you can rewrite the query directly in ProxySQL. So you just create a rules that define if this specific query is being executed, just rewrite it in a different way. And maybe just adding an index or forcing a limit or changing some syntax. Changing syntax is also very interesting. If your application is working with MySQL version A, and then you migrate to MySQL version B, the syntax is not valid anymore, or some keywords has changed, so you can use ProxySQL to rewrite the query on the fly. And again, you have different criteria to match the query and how to rewrite it. Another important features is the firewall. So you can have some very basic firewall, like just blocking some specific traffic, or you can have a more advanced firewall that is basically you create a whitelist of all the queries that are allowed to be executed, and everything else is being stopped. I'll try to be a bit faster. Another important feature is throttling. So if you identify an application that is abusing the database, you can actually create rules to slow down that specific traffic from a specific application. Now, I want to add a quick note about DB cluster and MySQL router that I mentioned before, and I want to compare them. So DB cluster is actually able to provide the HA as a built-in, and MySQL router does a great work of redirecting traffic to the primary or to the replicas. But they also have some limitation, like MySQL router basically works only with DB cluster. So if you're using different backend, it doesn't work. And also ProxySQL has way less limitation than MySQL router, or said another way, MySQL router has a limitation compared to ProxySQL. Like ProxySQL has absolutely no limit on the number of connections. As long as your operating system is able to handle more connection, ProxySQL can handle them as well. We have customers running hundreds of thousands of connections with absolutely no problem, while MySQL router has a limit of 50,000 connections. That was increased before 8.0.22. This limitation was actually 5,000 connections. ProxySQL has no limit on the number of clusters. So you can have ProxySQL connecting to 100 DB clusters, and at the same time to 100 AWS Aurora, and so on. We have customers using, again, thousands of clusters behind one single ProxySQL instance. Because of this, ProxySQL also supports several clustering solutions. And another thing interesting in ProxySQL is that it doesn't really care what MySQL version you are running. Because you can have a mix of 5.6 if anybody still uses it, 5.7, 8.0, 8.4, whatever. ProxySQL can handle any sort of backend. Can distribute traffic uneven. So it has several features compared to MySQL router. Real-time statistic, observability, all this is missing from MySQL router. Okay, so the last few seconds. Why choose MySQL? Well, it's extremely scalable. Again, hundreds of thousands of connections, thousands of clusters, absolutely scales. From the very beginning, was designed with performance in mind, so it is extremely fast. It's reliable, extremely reliable. Has security, has a lot of built-in security rules in the proxy itself, so that allow to have more observability, more auditing, and also filter traffic, and so on. Has a lot of observability, a lot of statistics are being exported. It is easy to adopt. Normally, you don't need to perform any application changes. Actually, often the application configuration becomes a lot easier. Just connect to ProxySQL instead of being aware of all the cluster topology. And it is trusted by companies of any size, from small startup with only few servers to large Fortune 500 enterprise with thousands of clusters. Okay, yes. It is suitable for any sort of clustering solution and is used in software as a service, gaming, fintech, and so on. Okay, last slide. Please try it out. It is open source project. You can download it. This is our website. There is the documentation. All the source code is on GitHub, and open to question, idea, suggestion, or even critics.